Good morning, people. If you're watching this in the morning, good afternoon. If you're watching this in the afternoon. So, we are here to discuss the prep paper number 1 hour 30 minutes timed. And we wrote this last week. So, this is the recording of the paper, discussion of the video, discussion of the paper. Whatever. Okay, question number 1 paper. Number of unpaired electrons present in cobalt 3 plus iron in its ground state. People, cobalt has a atomic number 27, right? So normally, if we write the electronic configuration of this, we'll get 1s2, 2s2, 2p6, 3s2, 3p6, 3d7, 4s2. That's how it goes. And they ask in number of unpaired electrons in gaseous cobalt 3 plus. Now we are going to remove 3 electrons. So first we are going to remove this person's electrons, right? So we remove those 2 electrons and then we remove the other one from this. So this becomes 3d6. So 3d6, they ask in number of unpaired electrons. So if we expand this and write there are 6 electrons in 3d. So that's going to be 1, 2, 3, 4, 5 and then 6. So number of unpaired electrons will be how much? 4. The answer will be answer number 4. Like majority of you have got this wrong. I don't know why. It's an easy question. All the thing you have to do is write the electronic configuration and then remove the electrons and then understand what's going on inside the D sub energy level. Right, that's answer number 4. Second one, a certain sample of carbon monoxide has only carbon 614 and oxygen 816 isotopes. Another carbon monoxide sample has C612 and 816 isotopes only. The property that shows significant difference. Now, people, when there are isotopes of different kind, the thing that will change is the mass. That's the main thing that's going to change, the mass. So people, when mass change, now reactivity doesn't change. Reactivity will never change. Molar volume kya hai people? What is molar volume? Molar volume is, I told you this in the class, the volume of the gas divided by the number of, volume per unit number of moles. Again, how many moles, how many volume is there per mole? What is the volume of 1 mole of sample? That is molar volume. So people, that doesn't change. No change in that. Polarity doesn't change actually with the change in, with the change in isotopes, the polarity will not change and chemical reactivity will not change. Now reactivity doesn't change with the, with isotopes, and then density will change because mass will change, density will change. So that one changes. So answer for the second one, answer number 4. Answer number 4. Question number 3, people. Consider the following statements related to the study of atomic structure. Electrons revolve around the nucleus in circular paths. Now, people, this question, electrons are revolving around the nucleus. This was told by Niels Bohr. Now, according to this part, I will cover in the revision class. I will give a short note for this, like the scientists and what they discovered. I'll give a short note for it. Soon I'll give it within this month. I'll give it. Electrons revolve around the nucleus in circular pathways. This was told by Niels Bohr. This was told by Niels Bohr. And then B part, cathode rays are negatively charged. This was told by Thomson during his, experiments. So here answer is answer number 2. Fourth one, a sample containing 10 grams of ammonium chloride and calcium hydroxide reacts as follows. Okay, let's see. The mass of ammonia produced here. So first, let's calculate number of moles of ammonium chloride. Number of moles of ammonium chloride will be how much? Mass or molar mass. So molar mass of ammonium chloride, we have to calculate. That's going to be 14 plus 4 plus 35.5. So that's going to be 39 and 43, 53.5. 10 divided by 53.5. So that's going to be how much? Give me a second. 10 divided by 53.5. That's going to be 0.1869. That's the number of moles of ammonium chloride. Then we have to calculate number of moles of calcium hydroxide. Number of moles of calcium hydroxide will be how much? Mass or molar mass. So 10 grams divided by molar mass of calcium hydroxide. That's 40 plus 16 and 16, 32 plus 2. That's going to be 74. So 10 divided by 74, that's going to be 0.1351. Now, people, who is the limiting reagent? We have to calculate. Now, both of them react in same mass. So we have to calculate who's the limiting reagent here. So the limiting reagent will be what? The one who is going to finish it. How are we going to calculate that? We are going to divide. Sorry, guys, there was a issue with the recording. Okay, look. Now, how to calculate the limiting reagent by using these details? We divide by the stoichiometry and see. We divide by the stoichiometry and see who is the limiting reagent and who is the minimum value actually. So 0.1869 you divide by 2 and 0.1351 you divide by 1. Now, who's the lesser one? Of course, this will be the lesser one, right? So that means ammonium chloride will be the limiting reagent. So number of moles of ammonia that is formed will be, you have to take from ammonium chloride. Now 2:2, that's 1:1 ratio. So same amount of moles will be formed. So 0.1869 moles of ammonia will be produced. Now what you have to do? You have to multiply this by the molar mass of ammonia. Molar mass of ammonia is going to be 17 grams per mole multiplied by 0.1869 moles. So that's going to be 0.1869 multiplied by 17. That's 3.1773 grams. 3.1773 grams. That's it. So that's going to be answer number 3, right? Answer number 3. Metana people, I have given answer number 2, right? I have taken answer number 2. No, 3. Okay, fine. This is 2, this is 3. Okay. I'll put the marking scheme in the group. In a while, I'll put it. Fifth one, people, number of stable Lewis dot dash structures that can be drawn for perchlorate iron. Now, people, this comes under inorganic on how to identify who is perchlorate, hypochlorate, perchlorate and hypochlorite, and how do you identify them? Now, people, this is the thing. There is chlorate, there is chlorite, and people, when you have low blood pressure, you call it hypochlorite, right? Hypotension. Hypotension means lesser one. So hypochlorite. It comes here. And then people, the one which you expect here should be hypochlorite. Hypochlorite, only what you should expect. But actually, that's not the case. We are going to cut off this high part. So you only have perchlorate. You only have perchlorate. So this is going to be ClO4 minus. This is ClO3 minus. This is ClO2 minus. This is ClO minus. There you go. So they're asking how many stable Lewis dot dash structures that can be drawn for perchlorate iron for this one. So we are going to draw them. 1. So actually the Lewis structure will be something like this. There will be 7 bonds for chlorine with a negative charge. And now, people, this thing can shift to all 4 places to get how many resonance structures? You have 4 resonance structures actually. Like this. 4 resonance structures actually. And you can draw another one to the bottom. Single bond to the bottom. Hey, see? You can see here now this bond is only changing places. Resonance structures. Resonance structures. So there are 4 structures that can be drawn. So therefore answer is answer number 4. Answer is answer number 4. Okay. There you go. And then question number 6. Question number 6. Which of the following statements is correct regarding group 15 elements of the periodic table? Okay, let's see. The ability to undergo hydrolysis of chlorides decreases down the group. Now that is correct, people. May chloride hydrolysis, when you are going down the group, it becomes reversible. For example, BiCl3, when you add it into water, it will form BiOCl and HCl, which is a reversible reaction, formation of white precipitate and all. So it's a reversible reaction. At the top people, they will undergo reaction fully. Forward reaction, no reversible, nothing. So that's true. Second one, now people, inorganic, I haven't done in the revision class yet night all. I'm going to give papers until inorganic. So I'm going to do my best to cover these theory parts in the questions, but not effectively, not like the revision class, but I'm going to just run through it because I haven't completed this part in the revision. So I don't know what kind of notes you have or anything. I don't know. I'm just covering the important theory parts for the question. That's what I'm doing. When we do inorganic in class, of course, I will tell you this part from where did it come in the note. I'm going to exactly show you from where did it come and how to study it and all. I'm going to tell you when you're starting inorganic. So in January, we are going to start inorganic. That means next month. Consist with elements which behaves as metals, non-metals, and metalloids. That's correct, people. There are all three types. Oh, ability to undergo hydrolysis decreases down the group. Which of the following statements is correct? Nedahanni. Think there's an issue with the question. Give me a second. Okay, there's a problem with the question, people. Here it should be incorrect. Which of the following statements is incorrect regarding group 15 elements? Now, first statement correct, second statement also correct. While all hydrides are polar covalent molecules, their boiling point increases down the group. While all hydrides are polar covalent, their boiling point increases down the group. You can't tell it like that because ammonia, ammonia has a larger boiling point than what you call pH 3. Fourth one, number of oxides are formed by highest number of oxides are formed by nitrogen. That's correct. Oxides amount, there are a large amount of oxides formed. There is NO, there is N2O3, there is N2O also, and there is NO2, and there is N2O5. Total amount of 5 oxides are formed, and that's correct. Fifth one, ammonia shows acidic, basic, oxidizing, and reducing properties. That's correct, people. Ammonia can show all these properties. That's correct. So, people, answer should be answer number 3. I couldn't tell you that this is incorrect. So, take all for this question. Take all for this question. Hurry. It should be incorrect. The goal should be to understand the theory part and learn something new through the question. It's not about competition right now. Right now, people, with 8 months to the exam, your idea should be not competition, but still your idea should be to learn these theory parts together with questions and face more questions. That should be your idea. So please correct this into incorrect. Seventh one, people, which of the following aqueous solution does not change any color or any precipitate with addition of sodium hydroxide dropwise? Okay, does not show any color change or any precipitate. Okay, aluminium 3 plus will form aluminium hydroxide, which will be a gelatinous white color precipitate, so we can avoid that. Fe2 plus will form FeOH2, which will be a green color precipitate. You call it dirty green. Copper 2 plus will form copper hydroxide, which will be a light blue color gelatinous precipitate. Not good. Then people, chromate. Chromate is yellow in color. Yellow color solution. When you add OH minus, nothing changes. It stays chromate. Cr2O2 minus is orange in color. When you add OH minus into the solution, it turns to CrO2 minus. They can have a conversion. Cr2O2 minus. When you add OH minus, it will convert to CrO2 minus. And CrO2 minus, if you add H plus into it, it's going to convert to Cr2O2 minus. So this theory part you're going to learn on the D block chromate. Chromate make chromium. Answer is answer number 5. 7th one, answer number 5. Yes. They're asking does not show. Okay, my God. Does not show. Answer number 4. This one shows. This one will show. So answer number 4. Nice. Right, people. Question number 8. This is a tricky question. Let's read it. The strength of H2O2 solution can be expressed as the main people, the volume of O2 produced at standard temperature and pressure. For example, a liter of 20 volume strength H2O2 will produce 20 liters of oxygen at standard STP conditions. That means, people, when you leave this solution, it will undergo decomposition. So it will form H2O and O2. So the ratio, the amount of, this is the reaction actually. What they're telling is, for 1 liter of H2O2, 20 liters of O2 is produced. So 20 volume strength means that. That's what it means. That's what is meant by 20 volume strength. Okay. If 1 liter produces 10 liters, then it is 10 volume strength. Likewise, it differs. So here 20 means like 1 liter will produce 20 liters of oxygen. That's what they mean. First of all, we have to calculate the concentration of the solution. Now, this H2O2 solution, we have to calculate the concentration. They have told 25 cubic centimeters of the solution was reacted. Now, people, 25 cubic centimeters, if we want to calculate the number of moles of H2O2 inside this 25 cubic centimeters, that's what we should do first. So using this equation, they have given a reaction actually, MnO4 minus plus H2O2. MnO4 minus will react to form Mn2 plus and O2. This one will reduce. Now H2O2 will reduce and MnO4 minus H2O2 will oxidize. MnO4 minus will reduce. So plus 7 to plus 2. And this one minus 2 to 0. That's going to be 2. And this is going to be 5. So 5 into 2 and 2 into 5. There you go. Now, people, the number of moles of MnO4 minus reacted. Number of moles of MnO4 minus reacted will be how much? 1 mole per cubic decimeter multiplied by 25 10 to the power minus 3 cubic decimeter. That's going to be 25 10 to the power minus 3 moles. 25 10 to the power minus 3 moles. Right. There you go. Right. From this table, you can calculate the number of moles of H2O2 in the solution. The number of moles of H2O2 in the solution. Number of moles of H2O2 in 25 cubic centimeters. In 25 cubic centimeters, that's going to be 25 10 to the power minus 3 moles multiplied by 5 divided by 2. Multiplied by 5 divided by 2. That's the ratio I'm taking, right? 2:5 ratio. 2:5 ratio. People don't calculate the moles of O2 which is produced from here. Okay, that is not volume strength. That's something else, people. Now, this is a byproduct of the reaction. It's the byproduct of an experiment. So that's not what it means. So, people, this is the number of moles of H2O in 25 cubic centimeters. So what I'm going to do is I'm going to calculate number of moles of H2O2 in 1000 cubic centimeters. Or you call it, or you can tell it like 1 liter. 1 liter at the 1 cubic decimeter. So you divide by 25 and multiply by 1000. That's what you're going to do. Divide by 25 and then multiply by 1000. Why am I doing that? People, for 25 cubic centimeters is this much. Now for 1 cubic centimeter, how to find? Divide by 25. And then for 1000, you multiply by 1000. Grade 8 maths වගේ එකක් තමයි මෙතන තියෙන්නේ. So 25 and 25 will cancel off. And then 10 to the power minus 3 and 1000 will cancel off. You will get 2.5 moles. 2.5 moles of H2O2 will be there now. Okay. Right. Now, use that equation now. This equation, this decomposition reaction, H2O2 plus H2O and O2. 2H2O2 forms H2O and O2. Right? So, number of moles of O2 produced will be half of this amount. Will be half. Half into 2.5 moles. Because stoichiometry 2:1. So, half. So, people, that's going to be 1.25 moles. That's going to be 1.25 moles. So how to calculate the volume of O2 that is produced? volume of water that is produced will be 1.25 moles multiplied by 22.4 cubic decimeters per mole. So per mole and mole cancel off. What you get is multiplied by 1.25. What you get is 28. That's the answer. 28 is the answer. So answer number 4. Answer number 4. Okay, now question number 9. Question number 9. Concentration of calcium phosphate solution is 0.02 mole per cubic decimeter. And find the concentration of phosphate in it in ppm. Now, people, one calcium phosphate contains 2 phosphate ions each. So, you have to multiply that by 2. So, concentration of phosphate, PO4 3 minus, will be 2 times 0.02 mole per cubic decimeter. That's going to be 0.04 mole per cubic decimeter. Right. Yeah, they're asking it in ppm. Now, to convert mole per cubic decimeter to ppm, ppm වලට අපි තව නමක් දෙනවා milligram per cubic decimeter. You have to convert this to milligram per cubic decimeter. That's what we do. And in the class, I will teach you how to do this. We are doing it in a triangular method. First, we have to convert mole per cubic decimeter to gram per cubic decimeter. From gram per cubic decimeter, you go to ppm or milligram per cubic decimeter. So moles to gram, how are you going to do? You're going to multiply by the molar mass of what you're going to do, right? What you're going to find out. So phosphate molar mass of phosphate, PO4 3 minus will be how much? 31 plus 16 into 4. 6 into 4, 24, 2 remaining, 4 into 1, 4, 5 and 6. That's going to be 65, 75, 85, 95. 95 grams per mole. Right? So you multiply by 95 grams per mole. Also, now grams to milligrams. Grams to milligrams, what you do? You multiply by 1000. So you multiply by 1000 and then you multiply by 95. That's what you do. So 0.04 multiply by 1000 multiply by 95. So 95 multiplied by 0.04 multiplied by 1000. That's going to be 3800 ppm. That's going to be answer number 5. Then people, question number 10 බලමු. Question number 10. 24 cubic centimeters of 0.1 mole per cubic decimeter KOH solution was required to completely react with H2C2O4. People, H2C2O4 is an acid, KOH is a base, so this is a neutralization reaction. KOH will react and it will form H2O plus K2C2O4. So 2 KOH will react with H2C2O4 to form two water molecules. Concentration and volume of KOH. So we can calculate the number of moles of KOH. Number of moles of KOH 0.1 multiplied by 24 10 to the power minus 3. That's going to be 2.4 10 to the power minus 3. So 2.4 10 to the minus 3 moles. Number of moles of H2C2O4 will be half of that in stoichiometric ratio 2:1. Half into 2.4 10 to the power minus 3. That's going to be 1.2 10 to the power minus 3. 1.2 10 to the minus 3. Now, then people, we have to find the concentration of H2C2O4. I'll calculate that and keep. Concentration of H2C2O4 will be 1.2 10 to the power minus 3 moles divided by the concentration of H2C2O4 reacted. So 25. 25 10 to the power minus 3 cubic decimeters. 10 to the minus 3 and 10 to the minus 3 will cancel off. So 1.2 divided by 25, that's going to be 0.048 mole per cubic decimeter. 0.048 mole per cubic decimeter. Then they are telling the volume of 0.025 mole per cubic decimeter KMnO4 required to completely react with 20 cubic centimeters of H2C2O4. Now we have to calculate number of moles of H2C2O4 in 20 cubic centimeters of H2C2O4. Number of moles of H2C2O4 in 20 cubic centimeters of H2CO4. Now we use the concentration which we found here. We are using that. So 0.048 mole per cubic decimeter multiplied by 20 10 to the power minus 3 cubic decimeter. Cubic decimeter per cubic decimeter cancel off. So that's going to be 0.96. 0.96 10 to the power minus 3. Yes, that's going to be the number of moles of H2C2O4 that's going to react. Now using this equation, we can calculate the number of moles of MnO4 minus that's going to react. First we have to write the equation. MnO4 minus reacting with C2O4 2 minus oxalate will go to carbon dioxide, and then MnO4 minus will go to Mn2 plus. Right, Mn2 plus. So it's plus 7 here, and then 0.28 minus it plus 8 and plus 6. And carbon dioxide plus 8, and then manganese plus 2. Manganese plus 2. So 8 minus 6, that's going to be 2. And then 2 minus 7 is going to be 5. So then 5 times 2 and then 2 times 5. So it's 10 here, and then 5 here, and then 2 here, and then 2 here. Okay, cool. Now we know the number of moles of H2C2O4. So we know the oxalate amount. Oxalate amount again, we are going to calculate the MnO4 minus amount. MnO4 minus will be 2 over 5 into 0.96. 2 over 5 into 0.96, 10 to the power minus 3 moles. They have given the volume. They have given the concentration, right? We have to calculate the volume. So we have to divide by the concentration. Volume of MnO4 minus will be 2 over 5 into 0.96 10 to the power minus 3 divided by 0.025 mole per cubic decimeter. So when you simplify everything, 0.96 divided by 0.025, and then you again divide by 5, and then you multiply by 2, you are getting 15.36. That's a perfect answer. That's an answer number 3. Question number 11. Which of the following is incorrect regarding H2O2? HNO3 is colorless. H2O2 is light blue color, pale blue color. This is wrong. First statement wrong. HNO3 only colorless when pure. When you keep it in a bottle for some amount of time, it becomes yellow color. You have seen in your chemistry lab. Sometimes HNO3 looks a little bit yellow color, because why is that? HNO3 is going to decompose to form NO2, which will cause it to turn a little bit brown color. But H2O2 may, if it was very pure people, concentrated H2O2 will be what? Pale blue color, not colorless. That's wrong. Can act as an oxidizing agent and reducing agent in any acidic or basic medium. That's correct. Shape of oxygen is angular. Disproportionate to H2O2 and O2 under UV. That's correct. H2O2 can form 6 hydrogen bonds. That is also wrong, people. There's nothing like it can form this much amount of hydrogen bonds. It can form 4 hydrogen bonds, but not like 6. So make it answers. Dekak ganna puluwan people. Answer 1 and answer number 5. Answer 1 and answer number 5, both I can take. So if you have put answer number 5 and I have put it wrong, please correct yourself in that. Okay, guys, question number 12. Which of the following is not an assumption of the molecular kinetic theory of gases? Answer number 1. Gaseous molecules are very small, hence their masses can be neglected. That's wrong. Masses cannot be neglected. If you neglect masses, then you can't do questions, actually. That's wrong. Hence their volumes can be neglected. That's correct. Collision between gas molecules are perfectly elastic. That's correct. At a given temperature, the mean molar kinetic energy of gas is a constant. That's correct, because it depends only on the temperature. Kinetic energy is equal to 3RT over 2. So it only depends on the temperature. Fifth one, gas molecules are volumeless point masses. That's correct. That's the exact definition. So answer is answer number 1. Question number 13. Which of the following is not a redox reaction? Not a redox reaction. So ammonium nitrate, that's a redox reaction that's happening there. Second one, dichromate reacting with KOH. In the basic medium, this is not a redox reaction, people. And fifth one is also not a redox reaction. This is a redox reaction. This is a disproportionation reaction, which is also redox. This one can be taken as a redox reaction. Then people, you can have two answers actually, answer 2 and answer number 5. Then people, question number 14, the de Broglie wavelength of a neutron traveling with a velocity v is lambda. If the kinetic energy of E of this neutron is increased 4 times, the new de Broglie wavelength would be. People, when kinetic energy is increased 4 times, what does that mean now? E is equal to half mv squared. E is equal to half mv squared. So energy, when you increase 4 times, people, the velocity becomes how much? 16 times. The velocity becomes 16 times because 4 squared, the velocity goes to 16 times. So when velocity becomes 16 times, they're asking what will happen to the de Broglie wavelength. Lambda is equal to h over mv. Velocity is inversely proportional to the lambda. So when velocity increases 16 times, what will happen to the, what do you call, de Broglie wavelength? It will divide by 16. So kinetic energy of this neutron is increased 4 times. The new de Broglie wavelength would be. Okay, there is no answer here. There is no answer here. So make it all ganda now, people. Question number 14, take all. In the marking scheme, I have given it as answer number 1. No, people. Wait. Sorry. My bad. Look at this question now. 4E. Energy is proportional to v squared, people. So when energy increases 4 times, the velocity will increase only 2 times because 2 squared is only 4. So 2 squared is only 4. So velocity is doubled, lambda is halved because velocity is inversely proportional to lambda. When velocity is doubled, lambda is halved. So therefore answer is answer number 1. All Gandepa, don't take all. My bad. Question number 15, the false statement regarding group 17. The acidity of hydrides increase down the group. That's correct, people. HF is a weak acid. HF is a weak acid and rest of the acids are strong acids. So you can tell when going down the group, the acidity will increase. Then second one, when hydrides are considered, HF has the highest boiling point. Actually, no. HI has the highest boiling point. HI has the highest boiling point. Then look at the third one. The bond dissociation enthalpy decreases as F2Cl2 Br2 and I2 downwards the group. Bond dissociation enthalpy. No, people. F2 falls to here. Somewhere in between I2 and Br2. Only bond dissociation enthalpy of F2 is going to fall. This one I'm going to teach you this part under group 17 in inorganic. Fourth one, people, although formation enthalpy of HF is exothermic, the formation enthalpy of HI is endothermic. Formation enthalpy of HF is exothermic. Formation enthalpy of HI is endothermic. Yes, HI, people, is a special case when it comes to formation enthalpy. We are discussing this in energetics lesson. HI has an endothermic formation enthalpy. That's correct. Fifth one, HF and HCl are not oxidized by concentrated H2SO4. Now HCl cannot be oxidized. HF also cannot be oxidized because F minus and Cl minus, you can't oxidize it easily. Right. So no, that's correct. That is correct. Right. So people, this one is answer number 3. Answer number 3. Second one, people, not second one. Yes, second one. When hydrides are considered, HF has the highest boiling point. That's correct, people. My bad, I told you that it's wrong. It is correct, people. HF has a higher boiling point than all other hydrides in group 17 because of the hydrogen bonding. So that's going to be answer number 3. Which of the following statements given below is true regarding emission spectrum of hydrogen? Lyman series belongs to the visible range. No, actually. Lyman series belongs to ultraviolet. Balmer series belongs to infrared. Wrong. The energy waves transmitted from N equals 6 to N equals 4 belongs to Paschen series. So Lyman, Balmer, Paschen bracket series, not Paschen. That's wrong. The lines of the Lyman series converge in the direction of decreasing wavelength. That's correct. People decreasing wavelength, increasing energy. That's correct. Sorry, that's correct. That's correct. So question number 5, answer number 5. The gap between lines 2 and 3 of the Lyman series are equal to the gap between lines 2 and 3 of the Balmer series. That's not correct. There are people answer number 4. 17th one, at a given temperature, the distribution of kinetic energies of molecules of a gas within a sealed container is shown in the following graph. Okay, now this is a Maxwell-Boltzmann distribution curve. They're asking some of the gas is removed and the container is resealed. Then the gas is cooled. Which of the following is correctly describe the change in the graph? So people, this represents the number of molecules with energy. I think people, now when you remove certain amount of molecules out of the system, what will happen? The number of molecules will decrease. So the curve will go down, right? The curve will go down. Curve will go down, obviously. And also they are telling they are going to cool. People, when they are cooling, what will happen to the energy? Energy will decrease. So the graph will shift to this side also. So it will decrease and also shift to the left. So area under the curve will decrease. So it's not increasing. No change with me. No change with me. So it should be decreasing and also shift to the left. Answer number 1. Answer number 1. Question number 17. Answer number 1. Yes. Question number 18. Now we will marking scheme make the marking scheme can have mistakes, or look at the discussion and correct yourself. There could be mistakes in the marking and correct them. Okay. The IUPAC name of cobalt, ammonia 5 and then OHNO2 is. So this one, this is amine group. This is hydroxy. This is nitrite, not nitrate, nitrite. So none of the above is correct. Okay, let's see, will you? Pentaamine. Pentaamine. Not amine, it should be amine, not second one then. Pentaamine hydroxido, that's correct. Pentaamine hydroxido, there can't be spaces. Hydroxido, cobalt, it's like +3 or +2, cobalt. Then my central atom, this one is +2 or +3. How do you decide? People, there's an OH minus. There's an OH minus. So OH minus should neutralize plus charge. So this nitrite is NO2 minus, people. So it will take one positive charge. It will take one positive charge. So if cobalt is +2, and OH minus is going to neutralize it, the total charge will be plus. So it's going to neutralize with NO2 minus. There you go. So cobalt 2 plus it is, right? So cobalt 2 nitrite. Answer number 3. 18th one, answer number 3. There you go. Right. 19th question, people. Which of the following liberates the largest energy when gaining electron? They're asking who is most exothermic. Nitrogen is endothermic, can't be. Helium is endothermic, can't be. Sulfur, carbon, and oxygen. Use the zigzag variation. So oxygen is here. Sulfur is here, and then carbon is somewhere here. So it's like this. So oxygen is the largest negative one. So it's answer number 3. Question number 19, answer number 3. Question number 20. Consider the reaction shown below. Now they have given enthalpy changes. They're asking enthalpy of vaporization of water. Water's vaporization reaction. Now, first let's write these reactions. H2 gas plus half O2 gas. I'm going to build up a thermochemical cycle for this. Look, same reactants will produce H2O liquid. This is vaporization. This is vaporization. So I'm going to write the enthalpy change for this reaction. minus 241.8 kilojoules per mole. And then here minus 285.8 kilojoules per mole. And then this one only I have to calculate. Right? That's the enthalpy of vaporization. So we can apply Hayes' law. This pathway is equal to this pathway minus 285.8 plus delta H vaporization is equal to minus 241.8. Delta H vaporization will be how much? When you take this to the other side, it's going to be 285.8 subtracted by 241.8. That's going to be 44. That's going to be answer number 4. Hurry, 20th one, answer number 4. Okay, cool. Look at the 21st question. Which of the following statements is correct regarding the below molecule? Carbon atoms denoted by A, B, C, D are found in the same plane. Same plane, you can paste it like a sticker, people. A, B, C, D is this one, this one, this one, and this one. So this one is sp2. This one is also sp2. This one is also sp2. This guy is also sp2. So everyone is trigonal plan. So you can paste it on a wall like a sticker. How is it? They are trigonal plan. Trigonal plan again, you can make them stay in one plane. Right? You can make them stay in one plane. So therefore you can tell all the carbon atoms in the molecule are sp2 hybridized, and also they lie on the same plane. That's correct. Now this benzene contains carbons here, and they are also sp2 hybridized. They are also sp2 hybridized. Okay, all the carbon atoms are sp2 hybridized. No need to worry. All atoms of the molecule are found on the same plane. All atoms of the molecule. That's also correct, people. Everything is trigonal planar here. Every atom is trigonal planar. So all lie on the same plane. That's correct. So it's answer number 5. Let's look at the D statement. The bond length between carbon atoms of the benzene ring and bond length between carbon atoms denoted by B and C are equal. No, that's wrong. Benzene undergoes resonance, so bond order will be 1.5 for it. How is the bond order of benzene will be 1.5? I'll tell that in detail. Benzene, people, like this. So it will undergo resonance structure with 2 resonance. How is the 2 resonance structures? So what will happen is the bond order. That means the probability of finding a pi bond here will be 1.5. Will be 1.5 sigma plus pi. But a double bond like this, it's a for sure double bond. It's a sure double bond. Sure double bonds, people, its bond order will be 2. So when bond order is larger, the length is shorter. They are not equal actually. So that's wrong. Answer number 5. Answer is answer number 5. 22nd one, the correct statement regarding the salts formed by S and P block elements are: solubility of hydroxide in second group elements increases when going down the group. Hydroxides, people, when going down the group, solubility increases. The best example is magnesium hydroxide. This guy is insoluble in water, forms a white color precipitate. Forms a white color precipitate, and when going down the group, the solubility will increase. The solubility will increase. Right. Then B, thermal stability of carbonates in second group elements decreases when going down the group. Right. Thermal stability. Now, thermal stability ගන්න කොහොමද? Polarizing power, polarize will do that within this month. The periodic variations will do that. So thermal stability, people, when going down the group, the polarizing power will decrease. So therefore ionic nature will increase. Ionic nature increase means thermal stability will increase actually. So it doesn't decrease, it'll increase. So solubility will increase, of course. Thermal stability will decrease. Thermal stability will increase. C. Acidity of oxides with highest oxidation state in third period. Acidity of oxides with highest oxidation states in third period decreases when going from left to right. In the third period. Okay, in the third period, people, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Highest oxidation state in third period decreases. Now, acidity will decrease when going from left to right. So, the acidity will increase when going from left to right. In the period, people, when going from left to right, acidity will increase. Why is that? Oxidation number increases. Oxidation number increasing means acidity will increase. So, meva details well in A levels, we don't talk this in details. If you want to learn that in detail, you have to go to university. In university, you will learn why oxidation number increases and suddenly why acidity is larger. You're going to learn that in university. I'm not going to go through details of that here. But in a class, in A level class, you're going to learn, okay, oxidation number increase, acidity increase. That's it. So, acidity of oxides with high oxidation state in third period decreases when going from left to right. That's wrong. Thermal stability of carbonates in the second group elements increases when going down the group. Thermal stability of second group elements increases when going down the group. That's correct, actually. So, people, question number 22, it's answer number 4. First and A and D correct. Answer number 4. 23rd one, correct statements regarding an sp hybridized carbon atom is presence of two VSCPR pairs in every instance. Of course, when sp, it means two VSCPR pairs. Have to form two sigma bonds in every instance. Yes, people, there should be two sigma bonds if it is sp hybridized. No, people, no. For example, carbon monoxide, check will you? Carbon monoxide, this carbon contains two electron pairs like this and with a negative charge. People, this carbon is sp hybridized, but it has only one sigma bond. That's not correct. Have two sigma bonds, that's wrong. See, all this forms a triple bond. Can't be. Carbon dioxide, for example, here this carbon is sp hybridized and it has no triple bonds, it has double bonds, so that's wrong. D, people, D, have to form at least one pi bond in every instance. Yes, at least one pi bond should be there. That's correct. Answer number 4. Answer number 4. Okay, right. 24th one, at constant volume, pure sample of oxygen exists, the temperature is increased such that the mean kinetic energy is doubled. Which of the following would get doubled? People, mean kinetic energy double temperature becomes double. Temperature becomes double. Temperature becoming double means mean square speed. Mean square speed will double because mean square speed is what? Mean square speed will be 3r T over m. So when temperature doubles, mean square speed doubles. Okay, of course, that is correct. When temperature increases, pressure also doubles. Pressure එක වැඩි වෙනවානේ. PV equals nRT, constant volume, constant number of moles. So therefore, when temperature is doubled, pressure will double, of course. Root mean square speed will not double now. This is root square root. So when temperature doubles, root mean square speed will, increase by root 2 times, not 2 times, root 2 times. That's wrong. First one, a mean speed of oxygen. Now, mean speed of oxygen. Now, this one, mean speed of oxygen is same like mean square speed. Mean speed of oxygen is same like root mean square speed, not mean square speed. Root mean square speed, both are same. So whatever this one is depending, this one also depends on the same. So we can take this statement as wrong. So answer number 3. Right. 25th one, which of the following is applicable for all three elements, zinc, cobalt, and nickel? They are all transition elements. That's wrong, people. Zinc is not a transition element. B, their ions form complexes with aqueous ammonia solution. Okay, zinc will form, cobalt will also form, nickel will also form. So that's correct. Their oxides are highly colored. Zinc oxide is white color, people. Only if you heat, only it will turn yellow color. Only if you heat only it will turn yellow color. That's wrong. Most stable ion in aqueous solution is a dye-positive ion. Most stable ion in aqueous solution is dye-positive ion. Cobalt can form +3 people. Cobalt can form +3. Cobalt can form +3. Yes, so then this statement is correct. Then answer is answer number 5. Cobalt paper +2 is more stable than +3. Right. Question number 26. Reaction happening at 25 degrees Celsius and 1 atm has an enthalpy change of -12 kilojoules per mole. Which of the following statements is or are true regarding this reaction? Right. The enthalpy change is -12 kilojoules per mole. Now what I'm going to do is, which of the following statements is or are true regarding this reaction? Okay, the delta H value for that reaction is -12 kilojoules per mole, which is happening at 25 degrees Celsius and 1 atm standard conditions. Statement number A, this reaction definitely has a positive entropy change. You can't tell like that. Definitely has a positive entropy change. It can have a negative entropy change, positive entropy change. Then B, the temperature of the system will increase when reaction proceeds. Temperature of the system will increase when the reaction proceeds. That's correct. This is exothermic. C, when 3 moles of reactants are consumed, the total heat that is produced is 36. That is absorbed. These are tricky questions which I have given you. Method release correct. Now what you did was 12 multiplied by 3 is 30. So of course this is the correct answer. So I took it as correct. No, that's wrong. Method absorbed neme people released. So this statement is wrong. Question number 26. Now D statement. Enthalpy changes when a catalyst is added to a system. People, catalyst cannot change enthalpy. People, enthalpy cannot be changed by catalyst. That's wrong. So it's answer number 5 here. So a lot of you people have put answer number 2. Because 26th and I told you like it's a tricky one. Because C statement is tricky. It's absorbed. I have put not released. Okay. Which of the following cannot be obtained by reaction of ammonia and chlorine? Now ammonia chlorine reaction. Ammonia reacting with chlorine. Normally it will produce N2 and HCl. When you put excess ammonia will react with HCl people. Excess ammonia will react with HCl. Like if excess ammonia when the reaction is complete, there is ammonia still left in the solution. So ammonia left in the solution will try to react with HCl. And it will produce ammonium chloride. And then chlorine that is remaining, if you put excess chlorine, it will react with nitrogen, forming NCl3. So these are the products that can be formed. They're asking which of the following cannot be obtained. So NCl3 can be obtained, and this one cannot be obtained. So it's answer number 5 here. Question number 28. Which of the following statements is or are not true regarding D block elements? Right. +4, +2, +4 oxidation states of vanadium, chromium, manganese, amphoteric. No. +4, +2, +4 MA, +4, +3, +4. That's wrong. Ionization energy of D block elements are higher than that of S block elements of the same period. That's correct, people. Ionization energy increase from S to D. Vanadium has the highest melting point while zinc has the lowest melting point. That's correct. We talked this in D block. All D block elements show colors. No, because zinc cannot show colors. So they're asking the false statement. So it's answer number 4. Which of the following statements is correct regarding usage of laboratory equipments and their properties? People, in a dropper, we don't add a final drop of the solution. No, people, not in a dropper actually. We use it for the pipette. In the pipette, we don't add the final drop of the solution. It's not for a dropper, of course. Pipette should be always kept vertical and the titration flask should be transplanted and solution should drip down through the wall. That's correct. People are going to learn this in chemical calculation, experimental part. When cleaning glass laboratory, we have to clean with acid before cleaning with base. No, people. Now, I'll tell you the scenario behind this. Glassware is made of silicon dioxide, which is acidic, people. Which is acidic. So when you first wash with a dilute base, you first wash this glass with base, people. ඉස්සෙල්ලම base එකෙන් සුද්ධ කරන්න ඕනේ. Then only you add the acid. Otherwise, what's going to happen is if you switch these things, if you first wash with acid and then wash with a base, and then wash with the base, first acid, then base කරොත් මොකද වෙන්නේ? The base will remain in the glass and it will corrode the glass. And it will corrode the glass. So that's not suitable. So people, we can consider this statement as wrong. In a burette, the 0 mark starts from the top. That's correct. Right? Burette 0 mark start from the top. That's correct. So answer is answer number 5. 29th and 5. 30th one. The difference in electronegativity for lithium and calcium is less than the electronegativity between beryllium and lithium. Lithium and calcium, people. Lithium is belonging to group 1 and calcium is belonging to group 2. And beryllium and lithium is like, close by to each other. So lithium and calcium, of course, should be larger, right? The difference should be very much larger than beryllium and lithium. To check this, check the Pauling scale, people. In the Pauling scale, I have given this in the periodic variation state, electronegativity variation. They have given you the Pauling scale. In the Pauling scale, you can check this. This is wrong. Sorry, this is wrong. Sodium oxide has a higher lattice enthalpy than magnesium oxide. Sodium oxide, people, it has sodium plus and magnesium contains magnesium 2 plus. Now, who has the larger charge? Magnesium has a larger charge, so polarizing power is larger. Polarizing power larger we are talking about lattice enthalpy. Oh my god, not lattice decompression temperature, lattice enthalpy. Lattice enthalpy we are going to learn this in energetics, people. Energetics, we are going to learn this. Lattice enthalpy is Q1 Q2 over is proportional to Q1 Q2 over R squared. There's an equation for this. We don't study the equation. Lattice enthalpy is Q1 Q2 over R squared. Q1 is the charge of the cation. This is the charge of the anion multiplied by charge of anion divided by the radius of the ion. Right? Radius of the ions. Then people here people, sodium oxide and magnesium oxide sodium oxide contains plus 1 charge then magnesium oxide contains plus 2 charge so lattice enthalpy of magnesium oxide is larger than sodium oxide. So that's wrong. Rate of diffusion of SO3 is larger than SO2. That's correct, people. So sorry, that's wrong because SO3 is a larger molecule. SO3 larger molecule, larger molar mass. So ability to run is less. Again, the speed is less. D statement, sodium can exist as a diatomic gas under certain conditions. That's correct. Again, under some conditions, it can exist as a diatomic gas. There's something. People, one, I forgot this. This is beryllium. Make a man barium. I saw it this as barium, people. The thing is, beryllium is a covalent atom. It's a covalent element, people. So beryllium actually 1.5, I think. Lithium is 1. Calcium is 1. Calcium is 1 then now. So actually there's no much difference between calcium and lithium. But beryllium is 1.5. Beryllium 1.5 kiyanne it's less than the electronegativity between beryllium and lithium. That's correct, people. The answer is answer number 4. 2. They're asking the correct wrong statement, false statement. So answer is answer number 2. Right. So let's go for the last few questions. So what I want you to do is I want you to cover one side. Again, when you're doing the paper, cover one side and then do the first side. Do this side first. First do this side and then open the other side and then do the other side. Don't do them together. Don't read this one and then read this one and mark. That's good people if you are good in chemistry. But if you're like, average and all, then you read the first statement and then read the second statement separately. I'm going to do it like that. Look at the 31st question. Oxygen always has a negative or zero oxidation state. No, people, sometimes it can have a positive oxidation state also. For example, in OF2. OF2 is a molecule and it has a positive oxidation state. N2O is considered to be a neutral compound. That's correct. It doesn't react with water when you add. So no acidity, no basicity. That's correct. Magnesium has a larger melting point than sodium. That is correct. There are 2 electrons delocalized. We are talking this on the metallic bond strength. Metallic bond strength. Magnesium has a larger melting point than sodium. So that's correct. The Lewis structure of a covalent molecule directly represents its bond angle. No, it directly doesn't represent. We have to find it actually. 35th one, the de Broglie wavelength of an electron is inversely proportional to the mass. A lot of students have taken this as correct, but it's wrong, people. Although lambda is equal to h over mv, although this shows that it's inversely proportional, the mass of electron cannot change. Mass of electron වෙනස් වෙන්නේ නැහැ people. Like, mass of the electron can't be changed නේ. එහෙනම් cut කරන්න. You have to cut the electron in half. එහෙම කරන්න බෑනේ. You can't do that. So this statement is wrong. Then 36th one. I'm running out of battery. 3% remaining. I hope I can cover this question set. Aqueous sodium hydroxide can be used to identify between aluminium 3 plus and zinc 2 plus ions. Actually, no. Both are going to react with sodium hydroxide and form a colorless solution with excess OH minus. Make inorganic color cover කරන point එක people. This statement is wrong. Sorry, wrong. Can be used. It cannot be used. 37th one. Covalent character of NaI is greater than that of NaS. Iodine, now the cation is same, the anion is only different. So this anion has a larger size than F minus. This anion has a larger size than F minus. So the polarizability of I minus is greater than F minus. So therefore, what will happen? The covalent character of sodium iodide is greater than sodium fluoride. That's correct. The solubility of all salts of alkali earth metals. Alkali earth metals කියන්නේ මොනවද? These are alkali metals. These are alkali earth metals. These are alkali earth metals. Solubility of all salts of alkali earth metals decreases along the group from top to bottom. No. Not all people. Some are different. I will tell that in solubility. Some are different now. Sulfate and all decreases down the group. Hydroxide increases down the group. Now sulfate and all decreases down the group. Barium sulfate is insoluble in water. But when we consider OH minus, magnesium hydroxide is the most insoluble thing in the period number 2. So likewise, it's different. Then people, melting point of HI is greater than HF. Yes, people. Yes, people. Now, in a previous question, I told you that HF has a larger boiling point, but the melting point of HI is larger than HF. So it's different. I'll teach you this in group number 17. Group 17 will learn this. HI has a larger melting point, but people, HF has the largest boiling point. So that's wrong. Sorry, wrong. Let me correct. Correct. Decomposition temperature, decomposition of HNO2 is a disproportionation reaction. That's correct. Now let's go for the second set of questions. Having positive charge on oxygen is considered to be unstable, like a Hari paper. Sometimes, like, when you're considering resonance structures and all, when it contains a positive charge, it's unstable. N2O does not react with water to show any observation. That's correct. So, people, this first one, answer number 4. Second one, 32nd one, it explains the first statement. So it's answer number 1 there. In metallic bond system, magnesium liberates 2 electrons while sodium liberates only 1. That's correct. Answer number 1. It explains the first statement. Using Lewis structure, the VSE pair, electron pairs, and lone electron pairs can be calculated. That's correct. Because you can count anything. Like 1, 2, 3, you can count. Answer number 4. The de Broglie equation is lambda is equal to H over mb. That's correct. Answer number 4. Easy. Aluminium and zinc are amphoteric elements and can form complex ions in solutions. Aluminium and zinc are amphoteric, okay. Amphoteric elements and can form complex ions in solutions. That's correct. Beryllium, aluminium, tin, lead, zinc. These are amphoteric elements. Beryllium, aluminium, tin, lead, and zinc. They are the amphoteric elements in chemistry syllabus which you are going to learn. Polarizability of halide ions. Now this is answer number 4. Polarizability of halide ions increases with increasing radii. That is going to be correct. Polarizability increase. Actually, it explains answer number 1. 37th one, answer number 1. Solubility depends on hydration enthalpy and lattice enthalpy. Yes, under solubility topic, I'll teach you this. Lattice enthalpy and hydration enthalpy depends on these 2 factors. This is correct. HF can form hydrogen bonds. That's correct, people. HF can form hydrogen bonds because it contains a fluorine and also a hydrogen attached to fluorine. And fluorine contains electron pairs and lone electron pairs. And there's hydrogen which is attached to fluorine, so they will form hydrogen bonds. Actually, it will dimerize. Dimerization vaya thamai venne. Like, 2 molecules will join together. Decomposition of HNO2 forms a monobasic strong acid. Monobasic strong acid is HNO3. It will decompose to form HNO3 and a neutral oxide, yes, NO of nitrogen. That's correct. Answer number 1. 39th one. Melting point of HI is greater than HF. HF can form hydrogen bonds, but still, people, HI is larger because it has a larger mass. Hinda, we can go for answer number 2 here. Here, answer number 2. 38th one, answer number 4. So with that, the discussion of prep paper 1 from question number 1 to question number 40 is complete.